Hello to all of you, this is Dr. Dhaval Maheta, and today we will understand how to create lift charts in logistic regression analysis. The lift chart measures the effectiveness of the models by calculating the ratio between the result obtained with a model and the result obtained without a model. The result obtained without a model is based on randomly selected records. Basically, we run logistic regression when one of our dependent variable is running in the categorical scale. The example of this is rural and urban, male, female, bias, non-bias, purchasers, non-purchasers, and my independent variable should be in continuous scale. There can be one dependent variable and many independent variables. We will have to divide the dataset in training, and testing. Let us see how we can do this in Rapidminer. So first of all, I'll bring that dataset which consists of one dependent variable and that also which is categorical. Heart is a dataset. I'll connect this spline with the result. I'll press this play button. Now this dataset consists of age, gender, chest pain, resting blood pressure, cholesterol, fasting blood sugar, resting ECG, max HR, exercise, old pick, ST slope, heart disease. Now the target variable is a heart disease. You can see it is in category. We want to predict, or rather we want to classify that on what factors, what attributes is influencing the heart disease. So I'll go in design and now I'll select the attributes. Kindly refer my previous videos to understand the flow of the lecture. Select the attributes, drag it and drop it here. From here, subset the data, select. I'll only select those variables which are matter of my interest. So I'll select age, cholesterol, fasting blood sugar, heart disease, old pick, resting blood pressure, and gender. Apply. Now I'll have to set the role. I'll drag it and drop it here. Here I'll have to specify which is my dependent variable. So the heart disease, I want to classify the heart disease. Make sure that the target role is labeled. Next thing which I would do is split the data. Now disconnect this spline and connect this with the example. Now one of the spline will go into the training data and another will be the testing data. So load the logistic regression now. Connect this to training. Next thing which you have to do is apply the model from here. Now you bring the model to model and the testing data which is in split will be connected to unlabeled. You can see 3 warnings are there on the nodes. The reason is that in split data we have not specified the parameters. Double click on it. You can specify that my testing data is 70% and training data is 70% and testing data is 30%. Click OK. Now you go in the operator window and activate the lift chart. Create the lift chart. Connect it. From model, label to example, model to model, and then we connect example to result and lift to result. Press the play button. Required parameter missing. You got this error because we have not specified what is my target class. So I'll write on here, yes. And then I'll run. You can see it has given me the lift chart. Now let us try to understand this lift chart one by one. First of all, let us go in example set. and try to understand this output. In the first case, there was no heart disease and the algorithm also predicted no heart disease. So here the things are given according to the row number. But I can also change this and say, arrange it according to the yes, right? Prediction according to the yes. Now here, what you can see is top 20 or top 28 cases are yes, and this are the actual heart disease. So this is according to the algorithm and this is the real. Now you can see the first case is misclassified, right? The algorithm predicted yes, and the person was not having any heart disease. Now let us see in lift chart how many cases have been considered. So 28 cases have been considered. So let us select 28 cases and try to find out how many misclassified cases were there. 1, 2, 3, and 4. So total 4 cases are misclassified in top 28 if you arrange it according to the yes. So first 28 cases, 24 are correctly classified. In next 27, 24 cases are correctly classified. In next 28, 23 cases are correctly identified. So this gives us a count. So this y-axis is basically telling me the count of correctly classified cases in top 28. I again repeat how you have to do it. See, here the confidence will be there. It will be randomly generated, or rather it will be according to the chronology of the numbers 1, 2, 3, 4, 5, 6, 7, 8. Now how lift chart is generated, it is based on the confidence of yes, or rather the target variable which we have specified. Make 2 clicks or do 2 clicks and make sure that here you get the probability, the proportion start from near to 1. On that basis, this 2 will be organized. Now you can see here the first case, which is a row number 152, algorithm predicted yes, but it was misclassified. So top 28 were picked up by the algorithm, and in that it was found that there are 4 misclassified cases. Then next 28, then next 28. On that basis, the entire lift chart is created. Now, you can see that there is one cumulative lift chart which is also running. So out of 24 cases, you got the accuracy, or rather the classification was done correctly. The percentages can be seen here. For first 20, in first 28, 24 were correctly classified, and that is taking the proportion of somewhere around 18%. Now this percentage will go on increasing, because when we take next 27 cases, again the classification will be more. So 24 will be added to 24. 48 cases were correctly classified. Then 48 plus 23. And on that basis, the entire cumulative lift chart is created. Now, what is the advantages of using this chart? Let us understand. In first 28, 24 cases were correctly classified. So I'll go in this and I'll specify that with model, out of 28, 28 cases were correctly identified. So without model, what was our threshold which we had specified? 50%. Yes and no, 50%. But with model, I am going 0.85. And so when I divide with model, without model, I'm getting the lift of 1.71, which is quite good. Anything which is above 1 is quite good. Let us try to understand why. The reason is, let's say for example, here it is 0.5 only. It means that, suppose if I go here, out of 28 cases, 14 were correctly classified by the algorithm. Then what does it mean? 14 divided by 28, it is 0.5. So with model is 0.5. Without model also it is 0.5, and the lift is 1. which means that the model is not working appropriately. Needless to say anything. So our model will only work when the lift is above more than 1. Now let us think of the adverse situation. What is the adverse situation? That out of 28, 10 were correctly classified. So 10 divided by 20. It means that the model is even worse than the normal probability. It has gone below zero point 0.5, and therefore the model is worse than the normal probability, and therefore the model is not at all working properly. So for the model to work properly, it is necessary that the lift should be more than 1. Now let us see for next 27 cases. It is 24 by 27. Let me write here 24 by 27. So 0.88 divided by 0.5. Yes, the lift is more than 1. Quite good. Let us talk about 23 divided by 28. So 23 divided by 28 is 1.64. Quite good. Now when you will go away, or rather, for the fag-in cases, out of 27, only 4 were correctly classified. So the model was developed here, but here the misclassifications are at the fag-in, right? That you can identify why the misclassification has happened. That also can be identified. So this is about lift chart, how to use a lift chart. For more videos on Rapidminer, kindly subscribe to my channel. You can see my playlist where I have already uploaded many videos of Rapidminer. You can follow me on LinkedIn and Twitter. Thank you.